Hello everyone, this is Mr. McMillan. I'm here with an instructional video on the similar 3D figures that we covered. And when you look back at the things we've done in this class, we talked about triangles and we talked about similar triangles specifically. And if you remember, similar triangles were ones where they had the same scale factor. Okay, so their sides had the exact same scale factor. So for instance, if a similar triangle or a triangle similar to another one and one had, or they had a scale factor of 2 and one of the triangle sides was 4, then the corresponding side on that other triangle would be 8 because you take 4 times 8. Now we're going to look at the same exact type of concept but with similar 3D figures. And we're going to see exactly how this affects the surface area and the volume between these two similar figures. Okay, so first we're going to consider the cylinder below. We're given the radius is 4 feet long and the height is 12 feet. And we want to determine the surface area and volume of the cylinder in terms of pi. So the radius here is 4 feet long. And the height is 12 feet. And we want to determine the surface area and the volume. Now, I'm going to assume that you know how to find the surface area and volume fairly easily with the calculations. So I'm going to list out the formulas. So for surface area, it's 2 pi r squared plus 2 pi r h. And the volume is pi r squared h. So if you want to take a minute to get the surface area or to just continue watching, that's fine. So 2 pi r squared plus 2 pi r h. R in this case is 4. And h is 12. If you were to add all of this up, 2 times 4 squared plus 2 times 4 times 12, and then stick it with the pi, you would get 32 pi plus 1 or plus 96 pi, which would be 128 pi feet squared. Likewise, for the volume, we plug in 4 in for R, 12 in for H. 4 squared times 12 gives us 192, and then of course, don't forget the pi, feet cubed. So that's the surface area and the volume of our original figure. Now, let's consider the cylinder below. Assume the cylinder is twice as large as the above cylinder. So what that means is we've doubled the dimensions of the cylinder. So the radius has been doubled and the height has been doubled. So if we do that, then our radius, our original radius is 4, we double that, so our new radius is 8. Our original height was 12, we double that, and our new height is 24. Okay. So I want you to think for a second. If the cylinder is twice as large as the above cylinder, then would that mean that the surface area and volume would also double? So you can think on that for a second. So let's check and see. We're going to do the surface area and volume of these of this cylinder. So we've got 2 pi r squared h, or sorry, 2 pi r squared plus 2 pi r h. 2 pi times r squared is 8 squared. R is 8, h is 24 now. And when you multiply that out, you get 128 pi plus 384 pi, which is equal to 512 pi feet squared. Then we're going to take our volume, pi r squared h. So we've got r is 8, h is 24. So when you multiply all that together, you get 1,536 pi feet cubed. Okay. So compare the surface area here to the surface area of the original. Is it doubled or is it more than doubled? And you should see that 128 pi, if we doubled it, would be 256 pi, which is not 512. So this actually does more than double the surface area. So we're going to figure out these ratios. First off, we're going to figure out the scale factor for the sides. Well, it says the cylinder is twice as large as the above cylinder. So that would mean our scale factor is 2. So if we do that, we get, we get 4/8 for the small over the large, which is 1/2. So that means that our ratio, we take the top number and put it first. Then we put a colon, and then we put the bottom number second. So our ratio of the sides was 1:2. Now let's look at our surface area. Our small surface area was 128 pi. And then we have to put that over the large surface area, which is 512 pi. If you were to type this in your calculator, simplify it, 128 pi over 512 pi would give you 1/4. So what would be the ratio of the areas? Well, 1/4, the top number goes first, the bottom number goes second. Then we'll do our volume the same way. So our small volume was 192 pi, and then our large volume, 1536 pi. And if you were to do that in the calculator, you would get 1/8. So what would be the ratio of the volume? That would be 1:8. Okay. All right, so in this third scenario, we're going to imagine there's a third cylinder that is triple the size of the first cylinder. So we're going back to the first cylinder and we're tripling its size. So we're going to answer the following. What is the length of the radius? Well, the original radius was 4 feet. So if we're tripling the size of that 4 feet, then the radius is now 12 feet. Then we do the same thing for the height. So what is the height? It's originally 12 feet. We triple it, and that gives us 36 feet. Okay. Now, I'm not going to sit here and go through all the calculations for the surface area and volume. You guys should have a pretty good idea of how to find the surface area and volume. So if you do all of that, you get 1152 pi feet squared. And the volume ends up giving you 5,184 pi feet cubed. So what is the ratio of the sides? And when we say sides here, we mean the dimensions of the one-dimensional thing. So the radius, if you take 4/12, because you've got 4, and then you've got over 12, the new one, 4/12 simplifies to 1/3. And so your ratio would be 1:3. Then we do the same thing for the areas. So our surface area of the small one is 128 pi. The surface area of the largest one we just did is 1152 pi. And if you type that in the calculator, you get 1/9. So your ratio would be 1:9. Then if we did our volume the same way, we would have 192 pi over 5,184 pi. And if you type that in the calculator and simplify, you get 1/27. So your ratio of the volumes would be 1/27. Now, if you look here, the ratio of the sides here, look at each one of these. So you go from 2 to 4 to 8. So what did you do to get from the 2 to the 4? Well, you notice that we should have multiplied by 2 to get to 4. And then what did we do from 4 to 8? Well, we multiplied the 4 by 2. Now, when we do that, this is 2 times 2. Now, another way to say 2 times 2 is 2 squared. And another way to say 8 is 2 times 2 times 2, which is 2 cubed. And I want you to think about the surface area and volume. What units do we typically use for surface area? And by that, what I mean is when we find the surface area, we say feet or inches or something, and then what do we put after it? Well, surface area, we put squared units. And what do we put for volume? Well, volume would be the cubic units. So this would be raised to the power of 3, or 2, excuse me. And then this would be raised to the power of 3. And that's the reason why this ends up working. Okay. So if we have the ratio of the sides or the scale factor, and we know the two shapes are similar, then we can just use this to determine a ratio for our volume or surface area and then find it respectively. You also notice the same pattern here. 3 squared is 9, 3 cubed is 27. All right, so let's look. We're going to do this page here. We're just going to talk about how we set up our ratios and how we do the ratio of sides versus areas versus volumes, give us general rule. Okay. All right, so first thing when we're solving for things for similar three-dimensional shapes, we always have to figure out our ratios for our sides or areas or volumes. The most important one is the ratio of the sides. So the ratio of the sides is always given to you by the ratio A to B. And like we said before, the first number is the top number of the fraction, the numerator, and B is the bottom number, which is the denominator. Okay. So for instance, if you had a scale factor of 2/3, what would be your ratio of the sides? Well, the ratio of the sides, you take your top number, 2, and then colon, and then 3. Now we talked about the ratio of the areas and how it uses squared units. So since it uses squared units, the ratio of the sides must be squared to get to the ratio of the area. Okay, so square ratio of sides. So for instance, you would have A squared to B squared. So if our A and B were 2 and 3, we would have 2 squared to 3 squared. 2 squared is 4. 3 squared is 9. And then your ratio of the volumes, we said volumes were measured in cubic units. So that means we take the sides and we have to cube the ratio of the sides. So we do A cubed to B cubed. So in this case, A is 2, so we do 2 cubed to 3 cubed. 2 cubed is 8, 3 cubed is 27. So that's if you're going from the sides to the area or volume. If you were going backwards, then you need to do the opposite of that thing. So the ratio of sides just chills out here because there's nothing to go backwards to. But the ratio of areas, if you wanted to get back to the sides, you would do the opposite of squaring a number, which would be square rooting. And for the volumes, you would do the opposite of cubing something, which would be a cube root. All right. And it gives you a little summary thing about what I just said there. Okay. So let's look at some examples. The first one is that two similar triangular prisms have heights of 12 meters and 20 meters. And it wants us to determine the ratio of the sides, areas, and volumes. So first off, we have heights of 12 to 20. Okay. So 12 to 20, we're going to do 12 over 20. And if you type that in the calculator and simplify, you end up getting 3 over 5. You could also divide both 12 and 20 by 4. So that means your ratio of sides would be 3 to 5. All right, so now how do we get to the ratio of areas? What do we need to do to our ratio of sides to get there? Well, like we talked about, the ratio of the areas have squared units. So we take 3 squared and 5 squared, and we get 9 to 25. And then we do our ratio of volumes. Volume is measured in cubic units, so we have to cube both of these, which would give us 27 to 125. Okay. Now that is obviously the ratio of the small over the large or small to large. If you were to do large to small, you would just switch the order. So it would be 5 to 3, then this would be 25 to 9, and this would be 125 to 27. Okay. All right, so that's all there is for scale factors and determining the ratios. Now let's use those ratios to determine the area or volume. Okay, so we're just going to do the first 2 examples here. So example 2, the figures below are similar. What is the area of the smaller rectangular prism? So it wants us to find the area, so we need to know what the ratio of the areas is first. Well, to do that, we need the ratio of the sides. So are there 2 sides here that we can use to determine that ratio? And you should see that we have one length here is 8 and one is 16. So our scale factor would be 8 over 16, which is equal to 1/2. So that means what will we put in our S here? Well, that'd be the ratio of the sides, so 1 to 2. Top number goes in front, bottom number goes second. Now, since we're doing the area, what do we need to do to our side ratio to get to our area ratio? Well, to get to from our side ratio to our area ratio, we have to square both of these. 1 squared is 1, 2 squared is 4. So our area ratio is equal to 1 to 4. Now you may be asking, well, how does that help you determine the area of the smaller figure? Well, if we know the ratio of the area is 1 over 4, then we can set up a proportion with what we know. So 1 over 4, the small is on top, so we need to do the small again. We don't know what that is, so we put an X over, and then we do 448, because that's our large one. Then how do we solve a proportion? We cross multiply, and you get 4x equals 448. Divide both sides by 4, and you get the area 1 is equal to 112 inches squared. You can verify that by taking 112 and dividing by 448 and getting 1 to 4 again. And then our last example here, example 3, the figures below are similar. What is the volume of the larger cylinder, excuse me? So we need to determine our side ratio first to find our volume. And we are given sides here, so we don't have to do anything fancy with the area. So our side ratio would be 2 over 6, and if you simplify that would be 1 over 3. So our side ratio is 1 to 3. All right, now we want the volume. Remember, to get from the side ratio to the volume, we have to cube this. So we do 1 cubed to 3 cubed, which gives us 1 to 27. And now that we have the ratio of the volume, we can determine the other volume. So 1 over 27. 1 is our smaller figure, so we need to have the smaller figure up top again, so that would be 9. And then we don't know what the larger volume is, so that would just be X. We have a proportion here, so cross multiply. And you get that X is equal to 9 times 27. And if you do that, you get 243 meters cubed for your volume of the larger one. And again, to check yourself, you can do 9 over 243, which is 1 over 27. So that's going to do it for this video, guys. Just work on the IXL T.9, get it to a score of 60. It's on this stuff. And we'll continue working on this at a later time. I hope this video helped you guys learn the material. I hope you took notes. Thanks, guys, and I will see you in the next video.